one STM. If you want to beat up on STM, pick one, pick its attributes, and find out what's wrong with it. Because there are some that I think really get time wrong, still get time wrong. Right? So if you don't have multi-version concurrency control, you either are going to be limited to scans, non-temporally related. I looked at this thing, I looked at that thing, I have no idea, I have no ability to look at two things at once. Or you're going to have some good, right? You're going to be back to, wait, stop the process so I can get my perception in the middle of it. Right? Without multi-version concurrency control, that's where you are. The other thing about STMs I think is super, super critical, is that granularity matters. Okay? If you're using an STM that forces you, or you're incorrectly using an STM, and you find yourself requiring a transaction in order to see a consistent value, you have got time wrong. Again. Okay? So STMs that require a transaction to read 4 fields of an object consistently are not doing time right. They're not really solving this problem. Okay? So, in conclusion, sometimes, I mean all the time, I think if you're suffering from excessive complexity, you got to think about changing something. And sometimes people actually do change. We move from languages that weren't garbage collected substantially to ones that are, because that reduces our implicit complexity. There's no other reason. But in the current state-of-the-art object-oriented languages, this conflation of behavior and time and identity and state is just making our lives much, much harder. And it's going to get worse. We need to become explicit about time in our programs. We really need to pay attention to the functional programming people who are saying, look at all these great properties of pure functions. They're there. They definitely satisfy whiteheads. We move forward by taking away the need to understand the insides of things. Okay? I believe that this ethical time model is worth trying. I think it's a general model. It supports multiple implementation ideas, and it will work in the local process. I'm not here talking about distributed computing at all. The other thing I can tell you is that the current infrastructures that we have are sufficient for experimenting with this, for doing the implementation. So so what is still unresolved here? Well, coordinating this internal time with the external world is going to become an important thing, and it's a hard problem. Tying STM transactions to I/O, transactional I/O would be a very interesting and I think possible thing. Again, overall though, you want to move away from transactionality. Transactionality is control, control, control. You want to become as happy as you can with the lack of control. That will give you more concurrency. There always could be more parallelism, and the more performance, and there definitely could be more work done on parallelism inside these data structures. There are more data structures to be done, I'm sure, in better versions. There are definitely going to be other time constructs. I think doing moving locking under this model is extremely interesting, because locking has some particular efficiencies that we'd want to leverage. And there's a way to understand it in terms of this. And I'll leave as an open question for everybody else. Is there a way to reconcile this with object orientation? And could we separate perception of an object from its identity enough so that we still get the benefits of objects, but we don't get a mess later?